Welcome to Data Skeptic K-means clustering, the podcast exploring the problem, the algorithms, enhancements, and use cases for K-means clustering. Any real-world use case of K-means clustering involves a close collaboration with organizational stakeholders, ensuring that a clustering result is both meaningful for the data and useful for some decision that needs to be made. In this episode, Mujtaba Anwer returns to the show to share insights from a real-world use case involving K-means clustering.
I'm Mujtaba Anwer. I am a researcher and a data scientist. In the past, I've been associated with Deloitte Consulting, and more recently, I've been working as a consultant in my own capacity with a gambling company based out of Finland. I am also a policy advisor on digital and data to a government entity in the GCC.
And as you know, we're doing our season on K-means clustering here. I'm curious if you could share with listeners if you have a recollection of when you first encountered this problem.
The first time I came across K-means was back when I was assigned onto a project where we were required to score employees, vendors, and contracts for fraud risk in a banking environment. Now, what we had was data from the likes of source systems such as SAP, Oracle, the legacy Oracle. And so mainly, we had data like from HR, procurement, and finance. A lot of our data was quantitative, but then we also had a lot of categorical data. And the situation was that the bank did not have an instance of fraud in the past. In fact, this was the first time they had set up fraud department, and we were doing this consulting engagement for them. So the moment when we talk about having no past instance of a fraud or something to look at or compare against or train on, the first thing that comes to our mind is unsupervised learning. And talk about unsupervised learning, the first picture in my head is of clustering, and within clustering I would say probably the most popular algorithm is K-means. So this is how I first came across it.
So you've got, as you mentioned, the lack of any labels, because there are no historical instances of fraud. Can't really use supervised learning, but is there at least enough data, enough training data that we can do something interesting?
Yeah, so we did not have any past instances of fraud. So essentially, we did not have any data to train a supervised learning algorithm on. Hence, we were looking for unsupervised learning techniques. We did have a lot of past data on employees, vendors, and contracts. Like what we're talking about is this bank was one of the largest banks in the country where I was based. So yeah, we had a lot of past data.
So I guess the hypothesis is that after you get a clustering result, presumably most of the clusters would be benign customer behaviors, but maybe, rogue accounts or fraudulent accounts would have similar properties and end up clustering into one place, and you'd identify some or maybe hotspots or patterns because there's a particular cluster or two you've picked out as bad. Is that the general hypothesis?
I mean, the general hypothesis, like when going into such a project, would be that we would run a clustering algorithm. It would come up with these big clusters which have very low fraud risk and some very small anomalous clusters that are farther away which might need investigation for fraud risk. Now, of course, this idea looks good, on the face of it, and it sounds good. But in actual reality, how such problems work when it comes to anomaly detection and fraud risk is that, there might not be just an obvious fraud, like an obvious anomaly. Like when people are doing fraud, the way they do fraud changes over time. And also, it's somewhere amongst the good guys cluster that there's that one anomaly that could still put them back in that good guys cluster. So what I'm trying to say here is that these sort of clusters we are looking at are not convex, are not those big fatty circles that an algorithm like K-means would come up. What we're looking for in a fraud risk problem are more like concave or other shapes, weird shapes that come up perhaps even close to the good guys because the bad guys want to blend in. That's the sort of clusters we want to investigate, and hence why K-means did not work for us. It's also worth mentioning that we had a lot of categorical data. So when you have categorical data, you move away from means and you go into modes and medioids. And in our case, running just the first test of like a k-medioid or modes was immensely computationally expensive, and secondly, did not come up with any results that were taken seriously by the business users. Because in clustering, the challenge always is that you don't have like something to compare against. What you have is you have to convince the management that these clusters exist, and they're real, and you should believe in them. That's the challenge.
Well, there's an interesting dilemma here I'm going to maybe ask for your advice on for listeners who might find themselves in a similar place. You had a really good instinct. Let's try k-means on this problem. Didn't get an obviously useful result with just that alone immediately. Looked into k-medians and k-modes. And again there, even though nice idea to try, didn't find exactly what you were looking for your particular problem. In theory, you could have kept throwing the kitchen sink at it, right? Well, let's try spectral clustering. Let's do this and that and the other thing. Or maybe at some point we give up and we try something else. How do you make a decision about a fork in the road like that?
That's interesting. I mean, I've read quite a bit about the k-means clustering and other clustering methods, and certain clustering methods are good for certain types of problems, or put it technically, certain type of distributions. So normally k-means tend to work well when you have a lot of quantitative data. And when the distribution of the data is relatively dispersed, when we're not dealing with a weird, extremely skewed or unusual kind of a distribution, in such cases, and also when from your business knowledge, you do expect some sort of big fat cluster to come up that's gonna, separate certain guys from certain other guys. And I have another example where we applied k-means successfully in a CRM kind of context, but normally you would want to move on and try other methods when your underlying data has weird distributions and you expect the clusters to be not convex.
Well, good idea on the fraud, even though maybe in that particular use case wasn't the right tool and found other solutions. Let's jump into the perhaps more interesting case where it did work out in the CRM situation. Could you set up the problem for us? What was going on?
Yes, so firstly, I'd like to set out the context. I was working for a retail client. We're talking about not the last 2 years, but a little bit longer ago, when, let's say, machine learning was still starting to get popular. So there was less of a corpus and information about it as widely available on the internet. So hence at that time it was a bit more common for us to do innovative stuff and try POCs and see what works. What we were dealing with was essentially a CRM situation where I was working with a CRM manager. And the idea was that, well, they've been sending SMS to a lot of customers. And what if we can come up with a cluster of customers that tends to respond better to SMS? And how do we come up with that cluster? Now we have information on a lot of customers, not necessarily to whom we have sent SMS in the past. So it's not like we've sent them SMS in the past and we've seen that they don't respond, blah, blah. No, we had a lot of customer data. Through that data, we would want to figure out if there's like a pattern, that if there's a certain cluster who responds better to SMS or responds better to email or responds better, we just wanted them to be put in distinct groups. So that was the problem we were dealing with.
You've already had one experience that didn't go exactly as planned with k-means. What gave you maybe more confidence that was going to be a useful tool on this occasion?
What gave me the confidence that it would be more useful, because I looked at the customer base of the company, like just did some exploratory analysis, and it was it's a well-known retailer. And from my own knowledge and walking into the store and speaking to the managers, they're like certain distinct groups who do purchase at the retailer. In fact, the way they have designed their product merchandise, their pricing points, they're actually geared towards various sub-segments. So it kind of gave me more hope that there are patterns. Of course, the retailer orders products based on those patterns, and that's why it manages to sell those products. And in retail, one of the key challenges is to keep the inventory flowing. You have to sell the season in the next 3 months. So if you're a really good product manager, if you use your data driven, you have spotted patterns in your customers, and then you order products for them kind of, in your head, you have an algorithm that they will end up purchasing in the next 3 months, you're going to do well in retail. So this company did well, and that's what kind of gave me the confidence that there were underlying patterns. And more than that, also, like, remember, in a fraud situation, a fraudulent guy would like to blend in as close as possible with the good guys. But in a proper marketing or a distinct user group situation, it's in a customer relationship management situation, we do have different customers. And finally, the country I was in had a lot of distinct groups of nationalities, so foreign workers coming in, and hence that gave us the confidence.
And what's the feature engineering process like here?
The feature engineering process is, with clustering, is usually the normalization, where you'd put like the data between 0 and 100, like normalize it on a scale. But of course, if you have like a categorical data, then you define it as a separate categorical. But I think in a lot of situations, it does help to normalize the data. But then again, if the data distributions are really weird, then, even normalization might not help you. I think at the end of the day, clustering is a little bit about luck. Like, it just might not work. So what I can tell you is another thing. Okay, now with supervised learning, for example, feature engineering can really help you. In the clustering situation, in the fraud case, one of the things we did was we actually created new data. We created hypotheses on what a fraud could look like. I used your American government's procurement website to kind of find a lot of fraud related hypotheses, and then came up with like 500 hypotheses, and then coded them out to create new data which was based on those 500 hypotheses roundabout. And on that data, the clusters were more convex and more useful. So I would say in a case where feature engineering can really help or turn the tables around when something is crashing, that situation was or would be when you actually just use some hypotheses to generate a new data set. But, that's a risky thing, and it's very specific for a fraud use case. Back to the marketing and CRM, I would say that it's using k-means or one clustering algorithm it's as much depends on luck and depends on what your underlying customers and data looks like. Normalization cannot really, or feature engineering of any sorts, in my experience, is not like something you can bet on big time to save the day. Like would be the case in supervised learning. Feature engineering can make a difference.
If I were in front of a whiteboard and I was going to talk about k-means, I'm probably going to do a scatter plot of dots, right, with some x and y, and those are my features. But when I think of the typical schemas for a users table in the databases I've seen, there's no x and y. How do we get from user table to our algorithm?
I just give you examples. So I have how many examples there? 107. So I'll give you a few examples. Customers who belong to the same household group with at least one key decision maker. Customers who have contacted the contact center to register to the loyalty program. All customers who have opened and clicked a newsletter and redeemed an offer. Customers who have shopped in the avenues in the last 3 months. Customers who have bought item X similar time every month. Customers who have had their personal data updated by contact center in the last 30 days. Customers who have submitted feedback survey through the app. This is just, it doesn't sound as useful, but I'm not saying that we used all of these 99, but customers who don't have a photo in the privileges in the app, customers who shopped in more than 2 countries, customers in the reactivation segment, customers with an online lifetime of over 30 days, customers who bought a discount offer, customers who have bought more than 3 brands. Because we are in a multi-brand environment, the retailer has 110 brands. It's an $8 billion retailer. So the database you're talking about is a huge database. And these people, the CRM managers are like, one of the guys, he was from like a large Indian retailer, and the other one from the UK, from Shell previously. So these people think it through. So customers who have more than one child, aged 2 to 3 years old. Now, of course, this is relative to the demographic. You got one on customers who have posted Google review, who have received more than 5 push notifications in the last 7 days, who have bought sportswear in the last 12 months, customers who have active offers on the app, customers who transacted more than 10 times in the last month, customers who have unsubscribed from the email marketing in the last 3 months, customers who have filled more than 5 VOC surveys in the last 2 weeks, customers who follow on Facebook. Not Facebook, it's something internal. Customers who follow H&M on APC. Now I want you to cut it out because we're dealing with H&M in the Middle East. So customers who follow H&M on APC but have never shopped at H&M. I don't know how they picked it out, because remember, the CRM guy was running his silo with his analysts who were generating some of the data, bringing it to us.
Thanks to our sponsor, ClearML. ClearML is an open source MLOps solution users love to customize. It helps you easily track, orchestrate, and automate ML workflows at scale. Machine learning is no fad. Your organization is only going deeper on investment. Don't let this be a source of technical debt. ClearML can improve every step in your ML workflow, making it a tool loved by data engineers, ML engineers, DevOps people, and data scientists alike. ClearML is hands down the best collaborative ML tool with full visibility and extensibility. As a contributor on a machine learning team, ClearML amplifies your efforts. As a manager, ClearML gives you the transparency and metrics to guide your team's efforts effectively when you can't get pulled into the weeds. Their solution logs your entire process, Your data and models are versioned, so there's no questions of provenance or audits that can't be done. Model repositories give you a clear view of available binaries, and you can deploy pipelines directly from code. Supercharge your entire development process. Go check out ClearML today. Visit clear.ml to get started. Thanks to our sponsor, Arctic Wolf, 2021 was a landmark year in cybersecurity. The rapid, piecemeal changes businesses made on the fly to infrastructure, applications, and access controls during 2020's huge shift to remote work were now under scrutiny, while security teams were still busy defending against a litany of attacks and attack methods. As the size, scope, and sophistication of attacks continued to grow, many organizations spent the last year overwhelmed by perpetual change, wondering when, where, and how things will ever improve. In early 2022, Arctic Wolf conducted a survey of over 300 global IT security decision makers to understand their priorities and anticipated challenges for the years ahead. Our goal was to understand their security roadmap for 2022 and to get a first-hand perspective on their current objectives and potential obstacles looming on the horizon. Visit arcticwolf.com/skeptic to find out what they learned. That's arcticwolf.com/skeptic. Well, it sounds like a pretty complete list. Well, after that, you run your clustering algorithm on all those different dimensions, and you're always going to get a result, right? Clustering always does some sort of partitioning. How do you decide if those clusters are really useful or a good fit for your data?
I mean, that's an interesting question. With clustering, it's always, I won't say difficult, but a puzzle to solve, as in how many clusters should you go with before. And it's not just about how many clusters we decide to go with. It's also about showing value from those clusters and whether they make sense to the business managers who would be using the clustering information to derive value and generate any additional revenues, if any. So from a technical point of view, I would say one of the techniques would be to use like different metrics to evaluate the optimal number of clusters, and then just go with what most of the techniques are saying. And when I say multiple techniques, I think most of us already know about the likes of elbow method that just deals with the total within sum of squares and the number of clusters. And we've got the salute coefficient, which has to do with the intra-cluster distance and the average nearest cluster distance. But I'll go beyond that and suggest the likes of the Kalinske-Harabas index. The Kalinske-Harabas index is a variance ratio criterion. So essentially what it does is that it gives you the ratio between cluster sum of squares and the within cluster sum of squares. So when I say between cluster sum of squares, I'm talking about the distance between the different clusters, and within group sum of squares or within cluster sum of squares is about how dense that cluster is. So it takes their ratio, and when you plot it, kind of also gives you like some sort of an elbow, but it's just a different way to calculate that. The larger, for the Kalinske, the elbow it looks the other way around. I won't say elbow, I will call it's like an uphill climb, sudden uphill climb, and then it goes sideways. So for the Kalinske-Harabas index, the recommended number of clusters is where the value of that index is the highest. I think that's the easiest way to put it. Apart from that, I would also suggest using the likes of the gap statistic. By the way, Keela, did quite a few people talk about gap statistic or no?
Not so many. I mean, it's definitely come up. It's popular, but we haven't gone deep into it if you want to share some thoughts.
Yeah, because it's a little bit complex. So, and I really want to share one more thing. This clustering is like when validating it, I did one more thing with the regression. But before we come to that, so with the gap statistic, like I have like a more advanced way to explain it and then very basic way. A basic way to explain it, which is essentially that it's based on the comparison between the actual data and reference data. So the actual data is the data you already have, and reference data is what it generates through some sort of a simulation. The reference data could be coming from a uniform distribution. So what we're looking for is that for which number of clusters do we find the largest difference between the curve of the reference data and the actual data. Wherever it's the largest is our optimal number of clusters. Now that's still a relatively easy way to put it. Like that would be in my layman's terms, but in a more technical way to put it would be like it simulates outcomes using different values of k. So the gap statistic essentially simulates outcomes using different values of k and then compares the total intra-cluster variation with their expected values under the null reference distribution. So when we say the non-referenced distribution, it is a distribution with no obvious clustering, and that essentially means some sort of a uniform distribution, as an example. It creates a reference data set that's generated through using Monte Carlo simulations. For each of the variable, we compute a min-max and generate values. That's the gap statistic. Wherever the difference is highest is our optimal number of clusters. I'll say these are like the 3 or 4 methods which are more technical. On a business side of things, you would have to look at, I would say, do another round of exploratory analysis once you've done the clustering, and look at the frequency versus the dimensions, and like do a bit of exploratory analysis and see if that makes business sense for your business stakeholders. Like, do they think that such a cluster could exist? If they are totally like, oh no, this is not something that makes sense to us at all, or if it's something that gives them a new food for thought, that yes, such clusters might exist, and then you would just run tests. We've done clusters, for example. The point where you feel most confident is after doing a little bit of testing, which also requires some investment in doing that testing, and for the business stakeholders to be willing to invest in that. Another innovative way, as I said in the beginning, is just to try. Kyle can tell more about whether it's a best practice, but now essentially what's the outcome of clustering? The outcome of clustering is got cluster number 1, cluster number 2, cluster number 3, cluster number 4, and 5. Let's say as an example, five clusters. Yeah. So these 5 clusters are 5 different categories. It's a categorical variable, categorical column, 5 different categories. What you can do is, once you have clustered your data, you can split your data set into 3 different data sets, which is train, test, and cross-validation, and then run like a multinomial logistic regression, trying to train and test the cluster and the cross-validation. If the regression tells you also with a good fit and a good fit in the training and testing for the similar clusters, it means that we haven't come up with something random. I've tried that, I've done that. Although if that works out, it kind of gives me a bit of a confidence that what we have, it fits. I'm not saying that it's real, that it's going to make us money or derive a lot of value, but at least it fits. But remember, with clustering, you've got, well, essentially what clustering techniques are. The convex ones pick a centroid or data point, and then they use innovative ways to measure the distances between the points, such as complete linkage and average linkage. And one of the linkages makes it an agglomerative hierarchical, the other type makes it partitioning. But at the end of the day, you are just trying to measure the distances in many different ways. And like whether you've come up with a cluster that's just pure randomness and might not even fit a regression, that kind of worry, if you want like to remove some of your anxiety, one of the way would be to do that regression. Like, it at least tells you you've got something that fits, and then if it also gets sold to your business stakeholders, that's your second win. And third one is if you do come across a cluster, which we did, that really help us isolate customers who were converting to the SMS. That's like a win-win, but there's also a bit of a human judgment involved in that, because we were running a certain campaign on the SMS that after EDA we kind of figured out, okay, this cluster might respond to certain campaign better, and let's try SMS. Okay, do that test. Let's try email with that. But we had our data set was particularly geared, like our ambitions were particularly geared towards SMS, because it's like one of those costly channels in CRM, because in the CRM side of things, you have SMS, web push, and email, and emails are essentially free. Web pushes are essentially free, but SMS can cost you. So we wanted to send like a bit more targeted SMS, and it helped us with that.
We went over some of these methods you could use to help decide if your clustering output is a good one. That's obviously a step you want to take before then passing along the results to the collaborator you have in the business who's going to make some decision. Could you talk about that interaction? How do you help that person best consume the output you've generated?
I mean, to start off within this CRM and digital marketing context, I would say you would be in a good position if you've come across someone who has at least used like advanced statistical methods in their dissertation during their bachelor's or master's degree. Like, if you come across someone who's never been to university, they might still be a great marketer, but for them to grasp any of your statistical approaches might become very tough. So because I was consulting, I came across all types of people in different companies. So I would say that people who already have like a master's degree and have done a dissertation with advanced statistical methods at least once in their life can kind of help you with those conversations. But to begin with anything, data science is an expensive exercise. Like, hiring data scientists is expensive, and then the compute they need is expensive, and they take a bit of time from different people to do the data understanding or the business understanding. So what the business does expect is some sort of an ROI, a return on investment on the work done. And that's also, I would say, in these days, it's also part of the data science scientist's job to show the value. And showing the value doesn't necessarily mean making the company money, but it does mean that showing the company that you've done something that is of value or could potentially be of value along the journey. And to do that, it goes back to that business case building where, as I said, once you've done the clustering, it would be a great idea to drill really deep down into the EDA and kind of put the pieces of puzzle together. And if you really can, you should like make a nice presentation with personas. Like, you can say, well, this is customer group 1, this is their persona, and put some pictures there and descriptions there that kind of do that based on the EDA. And what's a cluster? It's basically telling you that these people are similar. These are their attributes, okay? So put that together. Also within cluster, if there is variation, kind of map that variation or the ranges so that the business customer can know. So that's like the business outcome side of things. For your own knowledge, also, like for my own knowledge, I would also run that regression and find the weights of the various variables and see like which variable is the one contributing most to this cluster becoming the cluster that it is, like which is the heaviest variable that's driving these clusters. Like that's an interesting information. If it's something that's totally irrelevant, like firstly, when you're doing feature engineering, how do you even decide what is highly relevant to your data set? There is business understanding involved, but if there's anything that looks overweight in determining your cluster, I have not read any necessary research papers on it, but to me it would just seem like a red flag, but I haven't come across that yet, but it could. Back to the deriving value thing, so be confident about what you're saying, and that confidence comes from using the output from clustering and doing an EDA and some supervised stuff on it and really knowing it well. And I would say also have like a very brief, like a 1 slider or 2 slides on the weaknesses and the strengths of what you've done. So what sort of insight to derive and what not to derive. So it's not something, you've done clustering, but it doesn't mean that this is the end of the world. Like, this is the final word. Like the company should invest their budget or bet big time on this. There is a bit of testing involved with it, because at the end of the day, unsupervised learning requires the validation of the business manager. And when you're doing data science, it sounds like data science. Oh, we're doing science, so we came up with something using science, and science cannot be challenged, and a lot of that assumptions kick in. But unsupervised learning is not, in that sense, is not irrefutable science. It's a refutable science, and your business stakeholder needs to know that at the end of the day, it's their call whether this clustering we should go with the testing or not. It's one of those methods that gives you a bit more anxiety compared to, let's say, a neural network, which is very accurately predicting. So it kind of gives you a lot more confidence in the work you've done. But yeah, it requires working a lot more with your business stakeholders and for them to understand what are your strengths and weaknesses. And don't just try one method, try multiple methods. The work of a data scientist never stops. But if anything, make sure you just show value. You don't have to make money for the company, but show value and keep them excited.
And to wind up, could you comment on some of the ways the company was able to extract value from the clustering results?
In terms of the clustering results, through the EDA, we identified that the clusters had certain similarities within cluster similarities. And, I shared them with the business manager as part of the presentation, who was then able to use his logic and judgment to come up with campaign ideas that we can try on this set of customers on this particular cluster, or using the SMS. And we tried them on this different clusters, and certain clusters which we had a predisposition would do better did not just better, but a lot better. And I'm saying a lot better, we're talking about 70% conversion rate. But it's easy to say that, well, there could be seasonality, there could be a lot of other factors coming into play. It might as well just be a randomness or non-linearity. But one after another, like consistently, that the particular segment on certain campaigns did really, really well. So it was not a fluke.
Well, Mujtaba, any closing thoughts on this algorithm? I mean, you've shared a lot of experience and wisdom with listeners today. Any final advice?
Yeah, my final advice would be, not just with clustering, but with any machine learning, you need to understand the model architecture well. You need to know what's happening inside the model and what is it, to sum up, what is it essentially trying to do. Even if you're using multiple techniques, if they are very similar techniques and then they come up with very similar recommendations, you compare that with a slightly different technique like an autoencoder and then see the results and then, make your judgment. With clustering, you have to do a lot more homework after the model has been built. Normally with supervised learning, once the model is built and it's, let's say you got a nice R squared or low mean squared error, then a lot of the job seems to have been done already, and that goes into production. But with clustering, it comes down to selling it to the business stakeholders, comes down to doing the EDA for that purpose and really looking for the insights. And where possible, like not being complacent, might be that you might try 15 different clustering techniques before you get a sense like what is the consistent patterns that are coming up in the underlying data or in the underlying clusters based on the various different techniques. So be open to a lot more experimentation, scope it that way, as all of that requires time. Do not overcommit, but it's going to be more work than just running a supervised learning algorithm or doing feature engineering for that. It's going to require a lot more Sherlock Holmes investigation.
Good advice. Is there anywhere people can follow you online?
Yes, you can follow me on Twitter. I'm at onlymujtaba, ONLYMUJTABA.
Well, great, and we'll have a link to the show notes so people can follow you from there. Mujtaba, thanks again for coming on Data Skeptic and sharing your insights.
Thank you, Kyle.
That concludes another installment of Data Skeptic K-Means. Thanks to our sponsors today, ClearML and Arctic Wolf Networks. Myself, Claudia R. Rooster, as Associate Producer, Vanessa Bly, Guest Coordinator, show notes written by David Abembe, and our host, Kyle Polich.